Welcome to Business Analytics Marathon, December 2016 edition. We're excited you could join us today for Miguel Molina and Walker session, Real World Predictive Analytics. Thank you to our presenting sponsor, Pyramid Analytics, for their continued support of our event. With their help, PASS is able to provide another exciting virtual conference. I'd like to introduce you to the speakers of the hour, Miguel Molina and Walker. Miguel has over 15 years of analytics experience and is an Analyticus founder. Walker has over 20 years of experience in analytics, head of channel partnerships at Pyramid Analytics, and a frequent speaker at data platform events. Without further ado, here is Miguel and Walker with Real World Predictive Analytics.
Thank you very much, Donna. Good afternoon, everyone. So let me start with some fundamentals. So you've all seen this analytical spectrum at some point. So what we have on the left side, it's what we traditionally call business intelligence. This is the left side, and so we have descriptive analytics, diagnostic analytics, and pretty much this is what we've been seeing on the industry for the last 20, 30 years. This industry is fairly mature now. On the right side, it is something that is now becoming much more popular, and it's what it's called advanced analytics. So the main difference, if I may say, is imagine that right here in the middle, we have the present, and whenever you're looking at the past, is whatever we're calling business intelligence, and whenever you're looking at the future, this is advanced analytics. And the main difference is that right here in this line, you're using an algorithm that is going to help you predict or prescribe, or even you're going to use cognitive analytics to simulate human interaction. Something that we're seeing in the industry and that is changing is traditionally, and I'm certain you've all seen the evolution of analytics. There's a very common chart where you can see descriptive analytics and how it becomes predictive analytics and then prescriptive analytics, this maturity path. What I've seen lately is that organizations now, even though they might not have an enterprise data warehouse per se, they are starting to experiment on different use cases on advanced analytics. And that is a big change that we're seeing in the industry. And of course, this is due to a perfect storm that we're living today, which is the cloud, mobile, the Internet of Things, cheaper storage, cheaper processing. So all this is changing the industry, and it's pushing the advanced analytics field as never before. So we created an advanced analytics framework for our customers to understand or to grasp easier how the different use cases can be used. So let me give you some examples. So on advanced analytics, I'll go first on the titles of the framework, and then I'll give you some examples. So we have segmentation, and imagine a very traditional case for a retail company where you want to cluster your customers through different characteristics. So that is pretty much segmentation. Of course, you would use clustering analysis that will help you achieve this. Then predictive analytics, I think, is self-explanatory. You're going to try to predict something. The case that we're going to see today, and we're going to show you a demo on a student attrition predictive model, which is actually a model that tries to predict the students that are not going to come back the following semester. I guess the most traditional predictive analytics use case would be customer churn, and that is predict the customers that you're going to lose the following, or that have a high chance of attrition over the next months. And banks have been using this for a while now. Then we have prescriptive analytics, which is simulations. And here the machine actually tries several 100,000 or million different outcomes in order to maximize a specific variable. Think perhaps about an inventory. If you have very little inventory, you lose money. If you have a lot of inventory, you lose money. So what is the optimum inventory that you should have 2 months from now? So that's when you use prescriptive analytics. That's just an example. And cognitive analytics is something that is being pushed now, and it's basically you're combining artificial intelligence and machine learning through a reproduction of human behavior. Think about vision, think about sound, text, and we're gonna share a couple of examples of that. All right. So the case that we're going to discuss today is very much focused on higher education. And something that I wanted to stress before we start is what we call a use case. And it's important in the advanced analytics world, it's important to have clarity on what is a use case. Traditionally on business intelligence, the way to start sometimes is, okay, we have this data, let's see what is information that we can get from there. When you're jumping into advanced analytics, it's important to have the question that you want to have answered from the very beginning, and that is the use case. What is the initiative? In advanced analytics or data science, I'm certain you've heard the analogy of data is the new oil. And I think it's a perfectly good analogy, and not only because data is going to become extremely valuable, or it is already extremely valuable, but also because the way you approach oil is the same way you approach data, in terms of companies should invest in exploration, and that is where the term data science comes from. There's some error and trial and test, and also there is this hypothesis that you wanna try and you wanna have tested and you wanna prove. So there's the exploration, and there's also the refining. So the data that is generated out of any advanced analytics model should be easy to digest and easy to put into operation. And that is where the analogy, I think, just completes the concept. I love this chart. It came out of the cover of The Economist several years ago. It's called the data deluge. And it strengthens the concept of use case. And because the value of big data actually is in the little data. And if you want to approach an advanced analytics project without clarity on what is the question that you want to have answered, it's going to be really, really difficult for you to achieve anything. So the value of big data is in the little data, and that little data is going to come from what is the use case that you're going to try to achieve. So since we're going to be talking about higher education, before we actually jump into the student attrition predictive model, I want to share with you the way we approach different verticals, different industries, and how we identify the use cases. So what you're seeing right now is the value chain of a traditional higher education institution. So on the left side, we have the student recruitment, then we have student management, the evaluation of the students, the graduation, and then the alumni. Throughout this chain, you have marketing and campus management. And of course, academic management, research, and the universities should be continuously planning for new programs. So the use cases have a particular impact on any of these specific blocks out of the value chain. So student recruiting analytics, for instance. This use case would be, or the way we approach this with our solution is mainly we gather the information from the alumni and we identify the pattern of what makes a student successful. And that is what we call the student DNA. So think about where they live, think about the distance from the university, if the high school where they come from, if their parents have a higher education or not. All these variables are important in order for the marketing team at the recruitment moment to invest their dollars, their marketing dollars, wisely. So that is one use case. Another use case, and this has to do more with Internet of Things, is what we call space and area optimization. So if you're in the higher education field, you probably are familiar with, there's usually a disassociation between the reservation of classrooms and the actual use of the classrooms. So traditionally, professors reserve the classroom for the whole semester. But then at some point in the second month or third month, they start having labs or classes outside the classroom, or for any situation, they just don't use the classroom anymore. So universities have a challenge on providing additional programs if they don't have available classrooms. So what we're doing on this solution is we're putting sensors, presence sensors, to identify if someone is actually using the classroom, and we try to analyze that against the information that is reported by the reservation system. So that is one use case, and of course the space and area optimization has to do rather with, it's really frequently there's a lot of traffic on the north stairs and nobody's using a specific area of the university. So it helps the university plan on utilizing in a better way the areas that are being subutilized. The student retention, I'm not going to talk about it now because that's the demo that we're going to do. Then smart billing works a little bit. We've seen this use case in the insurance industry for many, many years now, which is you provide a risk for every student as you provide a risk for any person. So what are the students that are most likely not to pay? And if I have to give them a scholarship or some financial support, what is the financial support that they should receive in order to minimize their chances of leaving, but maximizing the chances or maximizing the revenue that the university is going to get? Another use case, and this is of course cross-industry, is a marketing mix model. Whenever marketing invests in different channels, think radio, TV, newspaper, online, what is bringing the highest value? And basically what we do is we identify the base, what is the regular flow of students that are coming to the informational sessions, and then you start assigning the different peaks to different channels. That way you optimize, of course through a mathematical formula, you optimize which channel should be invested the most. Career demand, and so there's a lot of information here that can be used from unstructured data. What are companies actually looking for through Monsters, through LinkedIn, and so on. Classroom analytics, I think it's a really cool use case. Instead of having sensors in the classroom, what we put is actually cameras. Just think about a very regular camera. And then through cognitive APIs, you're capable of identifying the sentiment or the emotion of the students at a particular time in a particular classroom. And then you cross-reference that with a particular professor or a particular grade or a particular course or cohort and so on. And of course, just because I get this question asked a lot, it works a lot on an anonymous basis. And then personalized education, which is in the higher education industry, this is a buzz right now, which is understanding how a particular student learns or prefers to learn. It could be online, it could be in a classroom, it could be a more traditional approach, it could be a blended approach, but the idea is that the system is going to learn and suggest how each student should approach the classes. So this is a very general picture from 30,000 feet above ground on different use cases used today in higher education. This is of course not a comprehensive list, but this is the way we approach it, different industries. I'm going to jump now into the student attrition predictive model, which is the real case that we're going to discuss right now. So what is the objective? So of course, universities should be responsible if a student leaves. And why? Because either they didn't recruit the right students, or because they didn't identify on time the students that were at risk. So what this model and this solution is trying to accomplish is to automatize the process of identifying those students in order to take a preemptive measure. So how does it work? So we tap into the transactional systems of the universities, where we gather what we call the student profile. And the student profile would be, what is the GPA from that student? What is their zip code? Do they have, if their parents are married or not, if they have brothers or not, any information that we can get from the student, and this is rather demographics. Then we get the student involvement. There are many studies that prove that if a student is highly involved in the university, even with extracurricular activities, is less likely to leave the institution. So the student involvement could be how many books he's getting from the library, if he's going to the gym or not, how many times this student is logging into the online system, every time that he logs in, what is the duration. Then we get also the payment information, how many days before the due date they pay or after, if they pay with check, cash, credit card. And then of course all the grades and the assistance, and if some universities have the punctuality. So all this information is taken into the cloud. And let me stress on something right here. All this information that we're gathering is completely anonymous. We don't need to know the student. You could give me just an ID. It could be an encrypted ID. It could be a fake ID. I don't really care. The model doesn't work that way. So all this information, we use historical information to train the model and to validate the model. And once we have that model ready on an ongoing basis, you input the information, you push it into the cloud, and we're actually using, and I'll show you the architecture in a second, we're actually using Azure machine learning, and then we're pushing an output. And this is what the university gets: the student ID, the risk score, and what is the driver that is pushing this student. It could be health related, it could be payment related, and so on and so forth. So what are some of the results that we've seen? So we've seen a decrease on the attrition of about 3 to 5% through the use of machine learning models. And as you can see on the bottom of the slides, we put on bold and proper intervention. And I'm going to stress this in a little second. So what are the retention model components for this particular case? So first we define the drivers, and we detect the key attrition drivers. And then the model works, we create a model, and we start predicting. Most likely, this is where the work of consulting companies or business intelligence companies or data science companies is going to end, most likely. You get the data, you give an output, either if it is a project or if it is a subscription. But what we've seen is that this is a very limited approach in order to get results. Why? Because then the most important part starts, which is the university should communicate with the students, should apply the solutions, and should follow up. So defining the drivers and identifying the students at risk in order to have a successful data science solutions, that would be only about 20%. Then 60% becomes the contact that you're going to have with the students. And then the rest is going to be the intervention and the follow-up. And I want to stress this because there are many times for us that are in the data science field or advanced analytics fields that the most common error is that you produce an extremely good algorithm, a very good model, very good dashboards, but then we lacked the skills to push this output into the regular process of the university or the customer. And then it becomes a really interesting report that nobody is using. So at the end I have some suggestions for the audience, but one of them is think about how you're gonna make this data actionable from the start. Okay, so let me share a little bit with you what is the architecture from a very high level perspective. So we have the transactional system. And then from here, we push everything into a SQL database. So we have a relational database. Azure Machine Learning then connects, runs the model, and pushes the information back into SQL. The information is pushed into analysis services, and then it is digested through pyramid analytics. And I'm going to share with you a little demo on what the customers are seeing. So let me give you a little bit background here on the demo. So the demo, depending on the university, the model runs every 2 weeks or 4 weeks, or for 1 semester, or maybe it's only 4 months. So in this particular case, by the way, all the information that you're going to see is fake. It is 16 weeks. Of course, the model runs in week 1, week 4, and as the semester is moving, the different weeks are going to appear. So we're going to pretend that we're on week 16, and we're going to choose a particular campus. We're going to choose Dallas. And we had to create 2 models here, one for new students and one for regular students. And we're going to focus right now on regular students. And why 2 models? Because new students, we don't have much information about them. We don't have the history. We don't know how they did the previous semester. We only know what we're calling the student DNA. So the model had to be modified. So this first screen, basically what it does is it helps evaluate how precise the model is. We divide the students by deciles in order to simplify for a university to have an intervention. So they're gonna focus on the deciles with the highest risk of students. And what you can see on the right side is the different variables, the different features, and how important they become for the model. And that is going to change depending on the campus, on the faculty, there are many variables that are going to change that. So let me share with you for a second the analytics on what we can see here. Again, I'm going to focus on regular students, and here we're going to do some modifications on these dashboards, and I want to show you also a bit of the flexibility of pyramid analytics. So we're going to share this visual, this chart, and we're actually going to create a stack bar like this, so we can see how many people is actually on the engineering faculty or business faculty. And what we're seeing here is the number of students per faculty, the deserters and non-deserters, then by age, by gender, per campus, if they have a scholarship or not. So I'm particularly interested right now in understanding how the different faculties relate with the gender. So, I want to analyze this in a different format, so I'm going to change it. Let's change the visual. Let's make it high. But because I want to see not female and male as deserter or not deserter, actually what we're going to do is we're going to pivot the chart. So now what we're seeing is we have the deserter and not deserter. And the red is the male and the blue is the female. So let's focus on engineering for a second. So I click on engineering, and then all the dashboard gets filtered. So we see for engineering, okay, mostly are male. I guess that could be expected. Let's see for business. Okay, that changed a little bit. Let's go all the way down to design. Of course, now it's becoming not half and a half, but it's going towards that. Let's do a different analysis now. So I want to focus on engineering by age, and here I can see in the different age groups that most of the deserters are on the age group of 31 to 39. here's where I have my peak. So I want to understand more about these 689 students. So let's check on these guys. And now let's dice them by campus, for instance. So those 600 plus students, this is the way they are divided. So 391 New York, 200 Dallas, and 91 Atlanta. Let me share another report with you. So here what we're doing is we want to identify, instead of looking at the number of students, what we want to see is what is the risk. And apologies here, it should say risk average per high school type. So let's go for another campus. Let's go for Dallas, for instance. And instead of architecture, let's go for business. And maybe let's focus on another age group, 31 to 39. So what we see is the average risk per high school type. The highest one comes from foreign high schools, without college type, and so on. Let me, and here we have a map. We can play a little bit with that as well. Per faculty, we see that this is interesting. The faculty with the highest risk is hotel management and tourism, and human sciences, and that is Mrs. Pell, has the lowest one. So it is also important for us to provide to the universities why are the students leaving. And so what we're seeing here is what is the cost. And again, the cost could change through time, which we could, now let's focus on a different campus. Let's go for New York. And let's go for week 1, which of course week 1 is where we have less information. And instead of new students, let's focus on regular students. And what we're seeing here is, okay, the variable with the highest risk is this one, then the number of courses where they are registered, where are they located, the high school where they come from. And this is information that the university should use in order, and this information should be very democratic across the whole value chain, because it's going to help recruitment, it's going to help not only student success and retention, but it's going to help the whole university. Okay, so here we can see, again, what are the number 1 causes for desertion, the number 2, number 3, number 4, because of course we can target them all. Let me clear this a little bit. Let's hide the empty rows. So let's see, instead of week 1, and this makes a lot of sense. For week 1, where we have very little information, for new students, the high school where they come from becomes the most important variable. Let's see if that changes for regular students on week 16. Yeah, the high school is still very important, but now the payment, actually the payment type becomes really important. And we did a project on in Latin America for working adults, exactly the same solution that you're seeing right now for working adults. And it became really interesting that the most important variable to predict whether a student was at risk or not was whether if they paid with check, credit card, or cash. So all the information that you get from the model gets pushed back to the university, either to their CRM if they have one, or even to Excel files. So we improvise here a little bit to create what could be a little bit of a CRM, where we get the student ID, of course this information is fake, the age of the student, the decile where they belong, what is the factor for them to live, in this case is attendance for this particular student, and their score. So here we have another student. And so on. Let me play here for a second on, so here we're seeing the business school. And this information, of course, if it is pushed to a CRM, is going to simplify, if you remember from the slide, is going to simplify how the university is going to track whether the solution is being proposed to the student. If he's, let's say, the university is going to propose some financial support or just to decrease the number of credits for the next semester. So a CRM would, of course, simplify all this, and the CRM could feed the model back. I have some final thoughts for everyone. So I get questioned a lot. Okay, this advanced analytics solution is really nice. So if I'm with a completely unique business or any industry, how do we start? Where do we start? So these are the top 4 suggestions that I have for everyone. So aim for a small use case that is going to be a quick win, that is going to bring a lot of credibility to your advanced analytics team at your advanced analytics efforts. Select a feasible and impactful use case. If you're going to start small and aim for a quick win, it might not be the most impactful use case, but go for one that is going to, that the chances of the model not working might be less. And most likely you already know which is the use case that is going to be most successful. And because you know already the quality about the data, you know already how frequent the data comes, you know already the pain of your institution. So the third suggestion is about pilot, measure, and repeat. And the fourth one, and it has to do with something that I already mentioned, is think how you're going to activate the data, how these insights are going to turn into action from the very beginning. And you might have to bring someone that is an expert on processes, and the processes are going to be changed for the output to be integrated into the daily activities. But that is really important if you want your use case to be successful.
Hey Miguel, you able to hear? Hey, sorry, I wasn't able to unmute myself for some weird reason. It just wouldn't work. So sorry about that. Sorry about that, folks. So yes, I did want to share a little bit more about broadly about today's presentation itself, right? So the approaches that we kind of shared today, while it is specific to one particular use case, or like Miguel likes to put it, one particular question being asked in the education space, saying, hey, will a particular student continue for the next year or not, and should I provision for their business for the next year or not for a college? The approach kind of holds true for pretty much any domain space. We wanted to try and make it real for you to try and show you how we approached it for a particular question, but the approach is pretty much the same. And like Miguel kind of shared, I think the approach starts with identifying what the question is. I've seen several implementations with customers where we've started off with saying, hey, we want to do a bunch of heuristics, right? Let's say text analytics. The immediate next question should be, so what are the questions that you're trying to solve? Usually what happens in a real life scenario is we start trying to throw together a bunch of infrastructure, try to figure out which are the right products and platforms that we should use for us to go solve for text analytics, and so on and so forth. All of those are great, but they should come later. I think where, from an approach perspective, the first thing that we should, if you're consultants helping other people, you should help them ask, or if you're doing this within your own companies, you should be the champion to ask the first question as to what is it that we are trying to solve. Once we're done with that, the second step in the approach would be to try and take some sample data, some historic data that you have, and try and figure out what are the right algorithms for you to be able to apply against these to make realistic sense. So there are tons of approaches out there. I'm sure you might have heard them in some of the sessions today. If not, there are tons of material out there which helps you through the process to understand what kind of algorithms and what kind of heuristic programs really help you solve what kind of data. For example, if you want to do clustering, there's one bit of or one set of problems that it'll help you solve. If you want to do association, there's another set of problems that it'll help you solve, and so on and so forth. So the second step really, after you've decided what the question is to take a sample of the data and then try and see what does it help you, which are the algorithms that you need to apply against it for you to get the best result. The third step is to figure out what is the platform that you want to run this in. In our case, for example, we use Azure and the Cortana Intelligence Suite for actually going and doing the analysis. You can use multiple different approaches. You can use an R engine, for example. You can write R scripts and use that as one of the ways. You can use an IBM Dr. Watson kind of a system for you to get that done. So the third step really is to get the platform. The fourth step is to then identify how you're going to now disseminate this information to your users. At the end of the day, while all of these really boil down to numbers, it doesn't make sense if you're not able to present this to your users in a meaningful way in which they'll be able to take this data and then be able to slice, dice, look at it in context of the rest of their data and the rest of their business. That's really the fourth step for you to solve, which is figuring out how you're going to present this. In today's example, for that we showcased, we used Pyramid Analytics as the presentation tool. You could have used Pyramid Analytics both as a presentation and a data crunching tool through an R engine. And the final stage is to figure out how you'll roll this out and give training. I think we kind of missed that, or I might have missed it during the presentation today, which is equally important in terms of training people to know what the data really means. Many times I've seen, especially I've seen this in manufacturing firms where this approach is used to control quality or any of those things that affect the line of business directly. People don't really understand what a number particularly means. A number is not an end in itself. A graph is not an end in itself. It is a visual to give you context to what is happening, but it has to be taken into a broader context. I think the final stage, or if I were to put it that way, I would even call it the holy grail to solve a real-world predictive analytics problem, is really to be able to do the last piece really well, which is help people understand what are the context in which the data that they are seeing is to be used. So those are the 4 or 5 steps that we need to take as an approach for solving a real-world BI problem. What we showed you today, again, just to repeat myself, is just one example that we've done. We've done several examples similar to the student attrition that you saw today, but the approach has always been the same. You start out with asking what the question is, go through the paces, and end with making sure that the users of the system know what is the context in which this data is being used. Miguel?
Thank you, Divakar. So I guess that's it from our side. I guess Divakar and myself were available for questions if you have any. Otherwise, Donna, we pass the microphone back to you.
If you have any questions, please type them in now, and we'll be glad to get them answered for you. Currently, we have no questions. It was a very thorough presentation. This BA Marathon is brought to you by PASS, a not-for-profit organization which offers year-round learning opportunities to data professionals. If you're not a member yet, join today. Membership is free.
Miguel, I guess that question is for you to take more likely. Any resources that you can think of that could help to to formulate the problems, right? The first step that we talked about.
Yeah. So I guess you've all seen, whenever you read what is the definition of a data scientist, you're going to see that it should have some mathematical background, technological background, no? Some white hacking skills, but there's always this component that is business knowledge. And I guess your experience on the business is going to give you the material to be sensible about what is the problem that you're going to try to solve. I'm certain we follow a methodology that I guess there's this advanced analytics methodology or data mining methodology called CRISP, and at the very beginning it helps you follow on some simple questions on what you're trying to accomplish, and that will help you a little bit. But from my experience, I think the business knowledge that you're going to bring to the business, that's going to be the most powerful tool to ask the right questions.
Now, let me also just chime in on that just a little bit. You're absolutely right, Miguel. It's the understanding of the business. Let's try and do this with a quick example, right? Hopefully this helps answer or at least give a direction to that to that answer, right? Let's say I don't know what business you're in. Let's say we take the same example of the student attrition, right? I think where we start off is take a look at what you have from a historical BI perspective. So everybody uses some form fashion of BI tool. If nothing else, they're using VLOOKUPs on a spreadsheet, right? So let's start with that and try and see what is the data that particular historical report is giving you. Now, based on that historical report, and I've done this exercise a couple of times, we start answering questions. For example, you get into a room with a bunch of business stakeholders, and then you start, whiteboarding this, saying, "Hey, shoot your questions that you have that you would like to get an answer to yesterday, and let's try and see if with our current BI that we have right now, we're able to answer those questions." It's think of it as an architecture design session or a whiteboard kind of an exercise, and you start throwing this out on sticky notes or on a whiteboard, and you start kind of classifying them. What you'll start seeing is themes that come out of different questions. These will be very subjective in nature, very susceptible to the language itself in which you're asking the question, but you'll start seeing themes come out. What I've seen work really well, in fact, even for a solution such as this student attrition thing that we saw today, was one of the questions that popularly came out was, is there a way for me to know what the attrition level of a student is going to be? The way this question comes out is multiple ways. For example, somebody could have said, hey, I'm not able to decipher how many rooms I need to have for the next year, right? I'm having challenges in scheduling, in calendaring. I'm having challenges with cash flow. It could have come from multiple different ways that it was being said, but being able to identify the problem was the theme which says that there is a student attrition as an issue. So that's typically how we approach this. Hopefully that approach makes sense for you too.
Okay, we had one other question, and that was asking if the Azure ML visuals, the demos, would be included in the recording. Those can be provided to the organizer if y'all would like, and offered to the participants. Everything that you saw on the screen will be included in the recording.
Yes, everything will be in. I'm guessing if the question was specifically the Azure ML visuals, I think that's an IP, part of IP that Analyticus has built. So reach out to Analyticus, and yes, we can work out how we can best help you with that.
So in terms of the visuals, remember what we saw was pyramid analytics. That the demo that we saw is actually the visualization and BI tool from Pyramid Analytics. And we can have those screenshots as well.